All right, so this is 3-5, and we're looking at solving equations with the variable on both sides. So we're taking it a step up from the last few lessons with one-step equations, multi-step equations, now equations with the variable on both sides. And I did ask the Lord to help us because I'm going to work it out a couple ways for the first, maybe one or two examples, but then you should be able to work it out a way that you prefer and understand how somebody else works it out because they are still using the properties correctly. Okay, so you have the title up here, and I'm going to work kind of scattered around this lesson because I want to make sure it's clear to you all. So just turn over one page to 170, page 170, because we're going to actually do some examples from here. Okay, so page 170, toward the bottom of the page, I want us to do number 5. So go ahead and write number 5 up there. 3 minus 4x equals 10x plus 10. So find that problem, write that down. Okay, what's different about this equation and the other equations of the previous lessons?
There's two variables.
Yeah, the variable is on both sides of the equal sign, or both sides of the equation. Very good. So you see how you have an x here and an x there? X stands for the same number, but before I start, what's going on with x, and then start working backwards, my first step, yes ma'am? Does someone have an extra? There you go. Someone should help you out. I look at the variable. I'm like, okay, what's happening to it? Well, 2 things here and 2 things there. Which one do I deal with? You actually want to get the variable to one side or the other first. I'm going to do this problem 2 ways. And then we'll discuss the 2 ways that we worked it out and see which one's good, maybe not so good, or preferred. Okay. I'm going to get the variable to the right. I'm going to send it only to the right, which means I'm going to add the additive inverse of negative 4x, which is positive 4x, to both sides. Am I allowed to add the same thing to both sides? Yes. And when I do that, what's negative 4x plus 4x? 0. 0 plus 3 is just 3. I have 3 on the left. What is 10x plus 4x? 14x, and then I still have that plus 10 over here. So do you see that I added the same quantity to both sides, and now I have the x on one side? Is that good? Yeah, because now you just solve it like a multi-step problem. What would you do next? So someone help me out here. Yes, ma'am? Good. Subtract 10 from both sides. And I'm left here with negative 7 equals 14x. Then what would I do to both sides? Harrison? By 14. Divide both sides by 14. And my final answer will be negative half equals x. Do you see here what's 7 divided by 14? Well, 7/14 is 1/2, and it's negative, and that's x. So be careful with that. It wasn't 14 divided by 7. It was 7 divided by 14, which is negative half. So that's my answer here on this problem. That's what x equals. Okay, you guys see from this point on, can you guys see what I was doing here? It's basically the review of the 2 lessons ago. It's this first part that we need to get nailed down. Okay, I'm going to rework this problem out a little bit differently. So I'm going to write the problem. It's 3 minus 4x. So go ahead and rewrite it. 3 minus 4x equals 10x plus 10. Straight, why do we have to do this again? Because I want to show you could do it a different way. If I do it a different way, I have to make sure I'm allowed to do what I'm doing, and hopefully I get the same answer. That's the goal, to get the same answer. Okay, so here's my second way. Remember how the first time I moved the variable to the right? What do you think I want to do the second time? Move the variable to the left. Okay, so this time I'm going to subtract 10x from both sides. Am I allowed to subtract the same thing from both sides? Yep, I am. So let's see what we're left with. So the 3 stays the same. What's negative 4x minus 10x? Or negative 4x plus negative 10x? Negative 14x. So I hope you can see this relationship right here. 10x minus 10x, 0. 0 plus 10 is just your 10 right there. Okay? Does this look familiar? Does this look like lesson 3-3? It's multi-step equation, so what do I do here? Help me out. What's my first step? I'm going to subtract 3 from both sides, and I'm left with what on the left? And I asked this for the review. What am I left with on the left side? Negative 14x. So not that negative didn't just disappear. He is still there. Equals 7. Then what do I do to both sides? Rosalind? Divide by negative 14. And I'm left with x equals negative 1/2. Oh, how convenient. We got the same answer, didn't we? Negative 1/2, negative 1/2. Okay, so look at your notes. Oh, good. You guys are doing it actually better than I would have done it. You guys are putting it side by side, some of you. So you're doing one way and the other way. Good. So now it's time to compare. All right, time for an opinion. Which one is easier to do? The first way we did it or the second way we did it?
First.
Okay, I heard. Okay, second, first. Any other first or seconds? Okay. Why was the first one easier? So explain to me why was it easier? Because most of you say first. Some of you may like second. That's cool. But why is the first one typically easier? Lily?
Because on the first one, you're adding a number instead of subtracting it.
Oh,
so
that's nice.
It's not, especially when you're subtracting a negative number from a positive number, it gets tricky.
Okay.
It's easier to just adding two positives.
Yeah, there's an idea there with the positive-negative relationship. Anything else you want to add? Yes, sir.
Well, I'm talking both ways because the first way, you added at the starting, but you added a one number, and then you went and subtracted 3 minus 10, or 3 minus 10,
Right here.
Pretty hard because their opposite would be negative.
So yeah, that can throw someone off. So like kind of what Lily said at the beginning, it could throw you off, or as Jack said, in the middle step, it can throw you off. These problems can be worked out either way. Okay, your choice. If you prefer this first way, great, do it the first way, but make sure you do it correctly. If you prefer it the second way, great, just make sure you work it out. Both types should show work. Okay, both of them should show work. And you should be able to come up to that same answer. All right, here's what I want you to get down for your notes. We just worked it out twice. I'm going to give you some goals on these problems. So these are things you need to keep in mind. Goals. Number 1, simplify both sides of the equation. And this will be more and more important as the equations get more complicated. Both sides of the equation. That's your first step. Okay, let's look back at this problem, see how that would have worked. Okay, do you guys see my original problem here? Okay, look at the left side. Can it be made simpler? Please answer wisely. Can it be made simpler? Can I combine these at all? Nope. Can I make this any simpler? Nope. So we say both sides are simplified. Right? That's your first step. And in this case, thankfully, they gave it to us as simple as possible. Number 2, get the variable on one side or the other. And I'll move in just a moment. I'll raise it up. Get the variable on one side or the other. Remember how we worked it? First time we moved it to the right, second time we moved it to the left. It doesn't matter which one you move it to, just make sure you get it to one side or the other. So either or on that one. Here's something that's going to help a lot of you. Here's a little hint. So I'll put a little asterisk here. Hint. Keep the variable positive. Keep the variable positive. That's a good key. You don't have to do that, by the way, but that maybe will help 80% of you, 60%, I don't know. But a certain amount of you will be helped by that. Keep the variable positive. Okay, look at the first way we did it. did we keep the variable positive? Look at your process. Did we keep it positive? Yeah, it was positive 10x plus 4x, 14x, still positive. The whole way it's positive. Look at the second way. Did we keep the variable positive? No, and that tends to throw us off. So if you just want to make it easier, keep the variable positive, we'll look at ways of doing that. And then number 3, here's the most important one. Important step I can give you, or goal. Solve. Period. Solve. Do it. You solve. Okay, just solve it. Once you get the variable to one side or the other, now you can solve it. If you simplify it, if you get it to one side or the other, then you just solve it like you normally would. Those are our 3 goals. You guys okay with those? All right, ready? On page 170, we did number 5. I want you to do number 6. Go ahead and do number 6. Do it your way. And again, as you're working this out, the beauty of math, guys, is not only is it very structured, but it's flexible if you know the rules. Like, you're going to do it great one way, and others of you are going to do it great another way. That's great. It's all great. It's all good, as long as you use the rules. Show me the work so I can see the beauty of your process. Okay, what I want to do here as you guys are finishing up is I'm going to work the rest of these problems to keep the variable as positive as I can. Okay, that's my goal. So how would I do it in this problem? How would I keep the variable positive? So did anyone do that or know how to do that? Matt?
Minus negative 3y.
Okay, so you subtracted negative 3y. What's another way of saying that? Yep, I'm going to add 3y to both sides. I got to do it to both sides, and oh, nice. What's 8y plus 3y? 11y, and I still have the minus 10 equals 2. Listen very carefully. Be careful when you're adding or subtracting something from both sides. You see how we're adding or subtracting like terms? You can't just say negative 10 plus 3y is negative 13y, or negative 7y. These are not like terms. You can't combine them. These you can. All right, and then this is basic right here. What's your next step here? Lily Mooney, what's your next step if you did this? Add 10 to both sides, and you're left with 11y equals 12. Last step here, Lucy? Divide both sides by 11. Do you want to convert this to a decimal? No, leave it as an improper fraction or as a mixed number. Improper fraction is the best, so that's how we're going to look at these numbers. If you write this, think that, oh, that's a little over 11, it's a little over 1, which is right there. Okay, how many of you got 12 11ths? 12 over 11. Did anyone do it by subtracting 8y from both sides? And you got 11, or you got 12 11ths? Good. You're allowed to do that. Anyone else? You subtracted 8y from both sides? I got 1. Okay, that's all right. Man, this is too easy for you guys. Let's do number 7. Oh, question.
Could we have turned that into a decimal?
You could have turned it into a decimal, but don't make it harder on yourself. Like, when you get right here, leave it like that, because now you have to do an extra step.
Because, yeah, I divided it
And
0.09.
0.09?
1.09.
Yeah, so that would be the answer, but yeah, leave it as 12 11. Save yourself some time. Okay, number 7. Oh my, fractions. Okay, if you're not sure what to do, I'll help you out. I want to keep the variable positive, so I have two choices. I'm either going to subtract 3/5 x from both sides, or I'm going to subtract 1/5 x from both sides. Which one do you think is going to keep it positive? Yeah, I'm going to subtract 1/5 x from both sides. Again, not the only way, but to keep it positive. So subtract 1/5 x. Remember, it's 1/5 x, not just 1/5. These will cancel out, and I'm left with 2/5 x plus 3 equals -7. And then this is a two-step problem, or multi-step equation, however you want to say it. What would you do next here? Subtract 3 from both sides. You're left with 2/5 x equals -10. And then what would be my last step here? And again, here you have flexibility. You can say this or that. So what would you do? What would you do here? I don't know. How many of you would just divide both sides by 2/5? Okay. How many of you would multiply by 5/2? Either way, it's going to get it, but I think the multiplication is going to get it quicker. Okay, this cancels, which is nice. I'm left with x. And then here, if you need it, you have that 1, and just cancel before you multiply. So I get -5 times 5 is 25. -25 is my answer. How many of you got that? Okay, I'm going to ask this question again. How many of you subtracted 3/5 first? Look at that. Nobody did it that way. Sorry, Swivl. That's okay. We'll let that go. How many of you feel pretty comfortable with this process? Really? Good. Look on page 169 and do example 1. You do example 1. And there are multiple ways to do it, so go ahead and figure it out. The tough thing about this problem is you have uncommon denominators, and that means you're going to have to get them when you're adding or subtracting, so be careful with that. So again, be very careful. Get those common denominators when adding or subtracting. Ooh. Starting to get a bit sleepy here. You guys are doing great, though, really. You're working hard, paying attention. I appreciate that, and I hope it helps you out. I can't stop moving or I might fall asleep. Yes, ma'am. Mm-hmm.
With this one, 8, could I subtract that and bring it over here?
You can, just make sure you get common denominators when you do that. Okay, and you can see the answer there. Did you get your 3/2 or 1 1/2? Yes? Yay? Okay, if you didn't do it, finish up. You still have some time. Okay, what I'm going to do for you is I'm going to introduce something to you. If you get it, great. If you don't, it's okay. Because I think all of you can work it out this way, and that's fine. Here's a little tip for dealing with equations with fractions. How many of you love dealing with fractions? You just love it. I can't wait to get common denominators and to get the reciprocal and multiply all that. You love it? Okay. Okay, one Swivl. If you don't love it, wouldn't it be nice to make this a non-fractional problem? Man, that'd be awesome. So what do? You just cross out those denominators. Well, you could do that, but your answer is going to be wrong, unfortunately. But there is one way you can do it. First of all, is it allowed to multiply both sides by the same quantity? Can you multiply both sides of an equation by the same thing? Okay, I'm going to do that. I'm going to pick a particular number here. I'm going to multiply both of these sides. Okay, I'm showing that both sides get multiplied by 8. Okay, so go ahead and write this problem down again. I want you to get the process. If you after this you don't get it, it's okay. I'm introducing this. I want to throw it out there because it will help you out in Algebra 2. Because these problems get tough, and I hate fractions. Not me personally, but I sense that people don't like them. Brian?
What was the answer?
3 halves. 3 over 2 or 1 1/2. Okay, so work it out this way, and I want to show you something. Okay, which property has to be applied to make this happen? Okay, ready? So what's 8 times 3/8? 24/8, which is also known as, anyone know? What's 24/8?
3.
Well, wouldn't it have canceled those two out anyway, so you got 3. Okay. What's 8 times negative 1/4 x? Well, I know it's negative, so what's 8 times 1/4 x? So could you cancel these? Sorry? So watch what happens. You cancel that, becomes 2. That becomes 1. Negative 2x. Do you believe me there? Is 8 times negative 1/4 x negative 2x?
Yes.
Okay, it is so far. Oh, that's interesting. Sorry, that's an equal sign. What's 8 times 1/2 x? What's half of 8? 4x. Oh, that's nice. And what's negative 3/4 times 8, or 8 times negative 3/4? I know it's negative. Negative, sorry, I heard it. 6. Okay, if you're not getting that, I'm doing the multiplication. These two, get my two products, and these two and those two products. Any questions on how I got those numbers? Okay, if I multiply both sides by the same quantity, is that allowed? Look at this problem right here. Can you do this one? Do it. Go ahead and do it. Your way. And it doesn't matter if you bring it to the right or to the left. It's simplified. You choose the side you want to bring it into, and you solve it. How many of you got 3 halves? Wait, what? That sounds really familiar. Oh, wait, I didn't write it up here. But was it on your paper 3 halves already? You got 3 halves again? Okay, can somebody who is maybe thinking, tell me, how in the world did I pick 8? Like, why 8? Like, I could have picked 7 or 20, but why 8? Lily?
Is it because 8's the least common denominator?
Is it? Okay. What's the LCD of these 4 fractions? So what's the least common multiple of 8, 4, 2, and 4? It's 8. That's the LCM of these 4 numbers. So if I multiply it by that number, it's going to cancel out all the denominators. Eventually, right? See how I cancel it all out? And now I have an integer problem. Very nice. Okay. That's a tool for you. 2 more examples. And it's going to get weird here. It's going to get very weird. Go to example number 3 on page 170. And go ahead and tell me what's different about this problem and the other problems we've been working on, because it's something different. Sorry, I heard it. Okay, it's not a fraction, but some of the other ones weren't fractions either. There's something special about this one. Okay. Looking at the left side of the equation or the right side of the equation, is it simplified? No, wasn't that our first goal? So this is not even simplified. How do I get it simplified? Did I write it?
Mr. Ray, you wrote the wrong example.
Oh, sorry. Sorry, Sylvia. How about this, Emery? Can you read it for me so I don't mess it up?
5n plus 4 equals 7. Parentheses, 9 plus 1.
Sorry, you said
Or n plus 1.
n plus 1?
Parentheses, minus 2.
2n?
Yes.
Thank you. Sorry about that, guys. We'll get to that. Example 4. All right, but anyway, are both sides simple? Nope. Is the left side simple or simplified? Yeah, can you combine those anymore? Nope, so that's simple. Is the right side simplified? So let's get it simplified. What would you do here? Distributive property. 7n plus 7 minus 2n. This guy didn't change. Is it simplified yet? No. Nope. How can I make the right side more simple? Yeah, what's 7n minus 2n? Aren't those like terms? 5n plus 7. All right. Is it simplified now?
Well, now you have to do minus
Good. We simplified it. Now we got to get that variable to one side or the other. So what do you want to do? Something strange is happening already. Okay, I'm going to subtract 5n from both sides. All right. And then I'm left with 4 equals 7. Wait, that's not true, is it? Is that true or false? Okay, this is a false equation. No matter what you do, it's going to be false. If that's the case, my solution is no solution. There is not one number out there that will make this a true equation. It's impossible. No solution. Now we're in Algebra 1. In pre-algebra, almost all of our answers had a solution. Most of them did. Almost all of them. They gave you a little peppering of these no solutions, but now, no solution is a part of your assignment, or part of your answers on basically every assignment. You're going to have at least one no solution or another type. How do I know it's no solution? All you have to do is this. If you see that you have an equation that is completely false, I hope you know that 4 does not equal 7. If that is completely false, it has to be no solution. There is no number that I can put into the equation to make it true. No number out there at all. All right, so I put a little note here to help you guys out so that you know what to do in this case. So here's a little asterisk again. When left with an equation that cannot be true, like that cannot be true no matter what you try to do to it, there are no solutions. There are no solutions. Does that make sense? You get an equation that's not true. There are no solutions for that equation. It can't be made true. You can't just change it and make it true. It's not. So when left with an equation that cannot be true, there are no solutions, and that's how I get that answer. That is an actual answer. No solution. Okay. Example number 4, last one here, and I'll let you go. Oh my. This is the one I was just really wanting to get to it. All right. First goal, get both sides simplified. Is that already accomplished? Nope. It's not simplified. So simplify it. Can you make that simple? Go ahead and do it. Make it simple. Interesting. That's a property right there. You guys know what it is? Right up there. It's a property. Yeah, you could say like here to here it's commutative property, but there's another property stated there of equality. Close. Symmetric. 9 plus 2x equals 2x plus 9. And think of it like this, like a butterfly, right? The tips of the wings, 9. The body, 2x, so you have your beautiful butterfly there. Okay, can I solve for x? Well, I'm going to try it out. Negative 2x on both sides. I am left with 9 equals 9. Is that true?
Hopefully.
Wait. You put 9 plus 2 equals 9 plus 2x. 7 plus 2x.
Can any number
So right
be
here?
x?
No, in the lower one. 9 plus 2x.
What did I do?
Wait, so any
Plus
number
2x.
can fit in the x.
Any number fits for x, which means what's your solution? All numbers. That's okay. I'm glad we got it cleared up. All numbers are the solution. Every single number you pick will fit the solution. Ready? Give me a number that's easy and not hard to calculate, just for fun. Yeah? 3. Ready, guys? Remember the original equation? Is 3 the solution according to my answer? Yes, but I don't know if that's true. What's 3 plus 1? 4 times 2? 8 plus 7? Yes, 15. Good. What's 3 times 2? 6 plus 9 is 15. So 15 equals 15. Give me another number.
21.
Not give. Oh, I guess you could do 21. Fine. Fine. 21 plus 1. 22 plus, times 2. 44 plus 7. 51. All right, remember that word, please. 22 times 2. 44 plus 9. Or sorry, 22 times 2 is 44 plus 9. 51. I'm losing it here. Is that what we said over here? Okay.
I have 44.
Oh, 21. That's our number. Thank you. 21 times 2. Sorry, I should have written that down. Which is going to give me 42 plus 9 is 51. So is that true? Any number will work. Negative 8 works. Okay, please. I'm going to write it down. How about that? Let's make it easy. Negative 8 plus 1. Negative 7 times 2. Negative 14 plus 7. Negative 7. I'll write that there. All right. 2 times negative 8. Negative 16 plus 9. Oh, my. Is there any number that will not fit? It works. You try it out. Yeah. Will fractions work? Will decimals work? All of them. Any number you think of will work. All numbers. So last note, and then I'll give you the assignment. You can start working on it. Here we go. Last note. When left with an equation that is always true, like 9 equals 9, that's always true. The solution is all numbers. And technically, if I wanted to be completely accurate, I would say all real numbers, because imaginary numbers, not necessarily, but all real numbers like we've been dealing with. Whew. Okay. Boys, okay? You want more homework? Is that what you're calling for? Yes? Awesome. I can do that. Okay, your homework that will be due on Thursday is, and you can get started, is 14 to 34. That sounds familiar. 14 to 34. And then there's a few more here. Oh, nice. 47 to 49. And that's pages 171 to 172. And that's due when? Thursday. So you can get a head start on it now. Tomorrow you have a quiz over 3-1 through 3-3. So everyone has that quiz tomorrow. If you haven't seen some of the videos, that's okay. You can watch them tonight. You don't have homework due tomorrow, but you do have homework on Thursday. Oh, wow. I'm going to move this over here. Sorry, Swivl. Okay. Bye, Swivl. Yes, ma'am.